One skill you need to have in calculus is being able to find where two graphs meet, where they intersect, and we know how to do that on the calculator. It's actually really easy. You just graph them and then you calculate the intersect, right? But what happens if we don't have a calculator? A, a lot of people find this very difficult, but it's actually not. We've been doing it forever. We call them systems of equations. We've been doing it, I believe, since Algebra 1, where we have two lines and we have to figure out where they meet. So if you remember way back, so pull it way out of here, that you would set the two equal to each other to be able to find where they meet. So that would be called substitution. Or you did elimination, where you lined them up and got rid of a variable, and that was elimination. We're going to do the exact same thing with functions that are not lines, but it's still totally possible to do it with any of them. We can algebraically find out where two functions meet on a graph. So let's take a look at that. So I have two methods written up here, but we're going to add a third method onto it. So method 3. Ooh, look at that. That is so nice. I never write nice on this thing. It's so bad. Elimination. One day I will be rich and I will buy a tablet that I can actually write well on. I can be all like professional looking. But for now, this is what you get. Okay, so our three options are: we solve one equation for a variable and substitute it into the other equation. Our second option is we solve both equations for the same variable and then we set them equal. And then our third option is elimination, where we stack them on top of each other and eliminate a variable. Okay, so we're going to start with method number 1. We'll do that one in purple. So we're going to figure out how to do this. Where do these two meet? Now, I want you to think first, before you do anything, I always want you to think, this is a line and this is a parabola. I know that because this has an x and a y, and this has an x squared and a y. Okay, so we're looking at where the line and the parabola meet. So how many places should they meet? They should meet 2. They could meet one place, they could meet no places, right? Because we could have something like this where it's like a parabola and then a line way down here that they don't meet. Or you could have the line that just touches the parabola, it's tangent to the parabola. Or you could have a line that goes through the parabola at 2 places, right? So we're looking at 1, 2, or 0 at this point are our options, right? If there's more than 2, you did something wrong. So, all right, first one is we're gonna solve one of the equations for a variable and then substitute it into the other equation. So I think what I'd like to do is just substitute in y, because then I don't have to like square anything, right? So if I just solve this first equation for a variable, if I just get y by itself, I have negative y equals negative x plus 1. And then so that equals y equals x minus 1, because I just divide both sides by negative 1. So this one, these are the same function, right? And so then now I know y equals x plus 1, and I'm trying to figure out where, if their x's and their y's have to be the same, right? Because these are meeting at a certain point, and x and y are the exact same at each of those points. So whatever y equals here has to also be y over here. So I can just go ahead and substitute that in. And I can just say x squared equals, not equals, x squared minus, and then instead of y, I'm going to write x minus 1 equals 3. Then I just distribute the negative sign. And now I have a quadratic that I need to solve. And we know how to solve quadratics, right? We factor. So we got to get the 3 over on the other side. So we have x squared minus x, and we subtract 3. So we have minus 2 equals 0. We got to get it equal to 0, then we factor. So what equals negative 1 and 2? Yep, that would give us negative 1 and 2. So we factor x minus 2, x plus 1. And then remember, we set each factor equal to 0. So we have x equals 2 or x equals negative 1. Those are our two options. Okay, so that's the x values that we got. And so according to this, it crosses at 2 places. We know that x equals 2 at one of those places and x equals negative 1 at one of those places. We don't know the actual points yet, right? These are just 2 x values. So we need an actual coordinate point where these meet. So what we do is we take the 2 and we plug it back in, and it doesn't really matter which one we plug it into. Let's plug it into the easier one, x minus y equals 1. So let's plug in 2 minus y equals 1, and then negative 1 minus y equals 1. We're going to solve these. So we subtract 2 from both sides. We have negative y equals negative 1, so y equals 1. And then we add 1 to both sides, and we have negative y equals 2. So y equals negative 2. Okay, so our 2 points that they meet, according to this, are 2, 1 and negative 1, negative 2. That's where these two cross. Okay, those are our intersection points. That's using method number 1. Let's try method number 2. Do this one in orange. We're going to solve both equations for the same variable and then set them equal. So we get them all so they say like y equals something or x equals something, okay? And then we just substitute in another, like by setting them equal. Okay, so which one do you think would be easier to solve for? Obviously, it'd be easier to solve for y, right? Because if we wanted to solve for x, we'd have to take the square root, and that's just messy. So we're going to solve these both for y. So I have y equals negative x minus 1, right? Because I subtract, nope, that becomes a positive x. I subtract x and then I divide by negative 1. And then this one becomes y equals x squared minus 3. See, even math teachers have a heck of a time doing stuff in their head sometimes. I probably should have just done the extra step there because hopefully I'm not leading you astray. Okay, so each of these says y equals, right? And since I need to figure out if y equals x minus 1, y also equals x squared minus 3, then I can just set those two equal to each other. I just pointed at my screen like you could see. You can't see. I can just set this equal to this, right? So I can just say where x minus 1 has to equal x squared minus 3. So again, we have a quadratic. We need to solve it by getting everything on one side and set it equal to 0. So we're going to have 0 equals x squared minus x. I add 1 to both sides, so I have minus 2. I end up with x minus 2, x plus 1. That's going to factor to the exact same thing I factored it to before, right? We're going to get x equals 2, x equals negative 1, and then when I plug those back in, I'm going to get the same points. Okay, so method 2 gives us the same answer. That's good. That means we did it right. Okay, so that's setting equal. Now method 3 is elimination. And everyone is like so afraid of elimination. Everybody just gets like weird about elimination. It is seriously the easiest one. And oftentimes it's the only one you can do. It is so much better. So just get a little bit used to doing elimination because it's great. So elimination, basically we just stack them on top of each other. X minus y equals 1. And then x squared minus y equals 3. And then we're going to add them together in a way that they cancel one of the variables out, right? So we either want the x squareds to go away, or the x's to go away, or we want the y's to go away. Obviously, in this case, we want the y's to go away because x and x squared can't go together. In fact, I probably should have written this like this: x squared plus 0x minus y. Because you can't, because otherwise you start to think that you can like add x's and x squareds, and we can't do that. So we're going to figure out how we can add these together so the y's cancel out. Right now, if I added them together, I'd get negative 2y, right? So let's just multiply this by negative 1. And so now I have negative x plus y equals negative 1. Remember, if I multiply it by like one side of it by, I have to multiply all sides, right? So I have to distribute this into every single thing, okay? Now I can add these two together, right? X squared minus x, the y, negative y plus y is 0. That equals 2, okay? So I just added them down. Now I'm going to solve this because now I only have one variable. We can solve things with one variable. X squared minus x minus 2 equals 0. Oh, guess what? X minus 2, x plus 1 equals 0, and we just factor it the same as we did. We get the exact same answers. So our points are the same for any one of these methods, which tells you, first of all, it tells you you did it right. Good job. But also it tells you that you can use any one of these methods that you're comfortable with. Just know that some of the times they don't work. Some of the times you can't do substitution or like setting equal, because if you had x squared and a y squared, it's going to be really, really challenging to solve for x or y. So that's where elimination comes in handy, because if you have like x squared and y squared in the same ones, you can eliminate them so much better. So there you go. Those are our 3 methods for finding intersections of 2 graphs without a calculator. And again, this is actually a very important skill to have.